Hello and welcome to the second video in the series on naming and formula writing for compounds, chemical compounds. In this video I'd like to focus primarily on ionic compounds and hydrates, and we'll do both names and formulas for those. Now when we do these, you need to remember a couple of things. One is we write the formulas, the charges of the cations, which as I explained in the last video are positive, and the anions must add up to 0, and that's how you get your formula. Now when you get that formula, you need to recognize that isn't actually a molecule that you're getting there. What you're getting is a formula unit, or kind of an empirical formula for a large crystalline structure, because when these ions come together they usually do so in large numbers, and you get kind of a large lattice work of ions joined up. So really what you're doing here is you're giving us the ratio of the different ions to one another. So let me do a few with you and we'll talk about how you get these formulas. So let's start. I have some samples here written for us. Let's start with the calcium bromide. What you're going to do is first of all look and you say, okay, I have calcium, which is Ca. Calcium is an alkaline earth metal, so they have a +2 charge. That's in the second column. We have bromide. And one thing I want to point out here is that the element here is bromine, but when it becomes an ion, when these nonmetals become ions, and it's a single atom that is doing this, we change the ending to IDE. So what I have here is I have calcium ions and bromine ions, and as I told you, or bromide I guess I should say, as I told you a second ago, these need to add up to 0. Well, you'll notice 2 and 1 don't add up to 0, so what I need is I need another one of these bromides at -1. So I have one calcium at +2, and 2 bromides at -1 each gives me a total of -2. So now these do add up to 0, so I just simply go and I write my formula. I have 1 calcium and I have 2 bromides. I put the 2 to indicate there are 2 bromides in my formula. So this would be the formula for simply calcium bromide. Now when you come down to this next one, we've got aluminum, which is column 13, and they are +3, and aluminum is typically +3, and nitrate. Now this is a little different. I'd referenced the individual element bromine that had become my anion in this case. Ates and ites as endings typically indicate what we call oxyanions, which were discussed in the last video, and that's typically a nonmetal and some oxygens that have covalently bonded as a group, and as a group they've typically in this case gained a few extra electrons, and so therefore they're an anion. So what I have my students do is we typically have them look up on a packet somewhere what a nitrate is, and if you look this up you're going to see that nitrates are NO3 and they have a -1 charge. Well, just like up above here, I need these to add up to 0. Since the aluminums are +3 and the nitrates are -1, what number can I fit both a 3 and a 1 into? And it's going to be 3. So I would need a total of 3 nitrates at -1 each to give me a total -3 charge, which will cancel out this +3. So I'm going to write this as aluminum, and I only have one of them, and then I write my nitrate, my NO3, and if I were to simply put a 3 here, that would almost look like I have 33 oxygens. Since this is a polyatomic ion and I need more than one of it, I must put it in parentheses and then put my 3 on the outside. So now this 3 refers to the parentheses, and that's kind of letting me know that I have not just 3 oxygens, or in this case 33 oxygens, but I have 3 NO3s. I have 3 of the whole nitrate ion. Now this next one brings in something else. You'll notice there's a 2 here. Now that may look like an 11, and I apologize for the font, but that's actually an II, or Roman numeral 2. I mentioned yesterday in the previous video, which I did yesterday, that you have certain elements, metals, in the transition metal area and sometimes in the lower groups like 13, 14, 15 that will have several different charges associated with them. Iron, cobalt, nickel, for example, can be either +2 or +3. Copper can be 1 or 2. I believe yesterday I misspoke and said that was cobalt, but copper can be 1 or 2. So you have these guys down here that can have different charges. You're going to need to look typically on a periodic table or something to see if it can have just one charge only, like aluminum is +3, or several different charges. If it can have several different charges, when you write the name, which we'll do here in a moment, you must include a Roman numeral so people know, is this nickel 2 or nickel 3? But this Roman numeral will always be referring to the metal in front. So what this is telling me is I have nickel and it has a +2 charge. Perchlorate I also discussed yesterday. Let me fix my 2 here a little bit. Perchlorate is based on the chlorate ion. Chlorate is ClO3, that's the most common ion, but I don't have perchlorate here. I don't have chlorate here, I have perchlorate. So what this is not ClO3, but ClO4 with a -1 charge. So what I went through in the video yesterday, the previous video, part 1, was that if you add oxygens but keep the same charge to the chlorate, it becomes a perchlorate. If you remove one oxygen from the chlorate, it becomes chlorite and so forth. But again, other than this, we simply have the same situation. I need 2 of the perchlorates, so what I'm going to do is I'm going to write nickel, and since I need 2 of the perchlorates, I'm going to do ClO4, and I need 2 of them. Since they're -1 each, I need 2 of them to cancel out the nickel, so it's going to be NiClO4 2. So this is how you would write the formulas, and notice basically I used the charges to determine how many of each I needed, and then I wrote the formula. Notice there are no charges, there's no Roman numerals in the formula, nothing like that. I use those things to find out how many I need, but then I just write the formula. Now, going in the opposite direction, when I want to write a name, you just simply look at the first thing here. This is a metal, so what I'm going to do is this is an ionic naming system. K is potassium, so I'll write that out here. And an SO4, and again with my students I give them lists of these things to use. SO4 is a pretty common one, you'll see that over time, and that's called a sulfate. And again, that's what I called a second ago an oxyanion, meaning it's a non-metal and some oxygens, and those end up having a -2 charge, which is why we have 2 of the potassiums. But I don't really need to worry about that. Potassiums are always +1. They're an alkali metal, so I don't really need to add a Roman numeral here. And really, the one thing you have to worry about is, do I need a Roman numeral? And in this case, I do not. Now with this next one, I actually will, and we'll talk about that here. Cr, if you look it up in your table, is chromium. Chromium can be either 2 or 3. And oxygen, remember as I said up here, you take the element and you change the ending to IDE. So I don't write chromium oxygen, I write chromium oxide. And then my question is, do I need a Roman numeral? And if you look, chromium can be either 2 or 3. So I do need a Roman numeral. How do I figure out which one this is I go back to my formula and I look at the charges. Oxygens typically are -2. I have 3 of them. So 3 times -2 means I have a total -6 charge. Remember I said the whole thing has to add up to 0, so my chromiums have to add up to +6. Well, if I have 2 chromiums that add up to +6, that means each chromium must be +3. Remember, 3 and 3 is going to give me my 6, so when I write my formula, since this is an element that needs a Roman numeral, and those are typically transition metals or lower, like 13, 14, 15 families, what I'm going to do then is add 3 bars, which is how you do, or 3 I's I guess, and that's how you would write the Roman numeral 3. So this is chromium 3 oxide. The next one I have here is Fe is iron, and please notice all of these are beginning with metals. Metals are elements to the left of the stair-step line that kind of starts between aluminum and boron, works its way down. So this is iron, and then SO4, notice I told you a moment ago here, SO4 is a sulfate, just like chlorate became perchlorate when I added an oxygen, sulfates become sulfites when I remove an oxygen, as long as they keep that same charge. And so what happens is this is not going to be iron sulfate, because it's SO3, it will be iron sulfite. However, the charge is still the same. Sulfates are still -2, just like the sulfates. So I have iron sulfite as my name. Iron is in the middle, it's a transition metal, and it can be either 2 or 3. Well, if I have one SO3 at -2, that means my one iron here must be +2, so it adds up to 0. So this is going to be iron 2. Oops, sorry about that, a little sloppy there. This is going to be iron 2 sulfate. Should have left myself a little more room in between them. Okay, so this is generally how you would write a formula, getting them to add up to 0, and this is how you'd write a name. Your big question when you really seem to do the name is, do I need a Roman numeral or not? And you can look in various sources. I have my students look at their periodic tables, which list the different charges that are available. Now, one other thing that happens sometimes is as these crystals form, sometimes you get water in there, in the crystalline structure. And in this case, what happens is for every one of these, I have 5 water molecules trapped in the structure. And so what happens is these are called hydrates, and typically hydrate naming, the beginning thing will always, in my class, will always be an ionic compound. So the rules are the same as we've been doing before. And then I'm just going to add one little term here at the end to kind of explain this, and that's going to be a prefix and the word hydrate. But the first part, I'm just naming the ionic compound. The prefixes I use are listed here. You're going to see this both in this video and the next video, because in the next video we're going to be doing binary covalent compounds, and I will use these prefixes for that as well. But I'm going to use these prefixes to simply tell me how many waters are there. So let's just do this one. Cu is copper. And SO4, as we saw over here in the previous section, is called a sulfate. Copper, if you look on a periodic table or whatever reference you're using, can be either 1 or 2. So I have to figure out which one this is, and I have to put the Roman numeral in the name. Well, if sulfates are -2, which we mentioned over here, I have 1 copper, so this copper must have a +2 charge so that it adds up to 0. So this would be copper 2 sulfate. And then what I do is I add the prefix for 5, which is penta, and then hydrate. So this is copper 2 sulfate, and then I just write penta hydrate. And that's all you do. So this would be the proper name here, copper 2 sulfate pentahydrate. And again, this first part was ionically named, and then I just added this prefix and the word hydrate at the end. Here's the reverse case where I'm given the name and I want the formula. And so what I'm going to do here is iron 3 chloride. Well, iron 3, of course, is iron with a +3 charge. Chloride refers to chlorine. Notice this IDE ending. IDE endings oftentimes, not always, there are a few, but oftentimes will refer to a single element, a nonmetal element that's acting as your anion. So this is chlorine, column 17, the halogens are -1. For this to add up to 0, I'm going to need 3 chlorides for this 1 iron. So my formula is going to be FeCl3. Notice I don't do parentheses here. I used parentheses over here when I had more than 1 polyatomic, but since this is a single type of atom, I don't need parentheses because there's no confusion. That 3 is referring to just this chlorine. When you see the hydrate thing at the end, basically you add a raised dot, kind of like a time symbol. Hexa, if you'll notice here, is the prefix for 6, and then that's H2O. And so that would be iron 3 chloride hexahydrate. Okay, I hope this helps you. Our next video we're going to get into, we're going to do the binary covalent, and we'll use those prefixes. I'll see you then.